Again, good morning, good afternoon, good evening, everyone. Thank you for joining this webinar. So today we'll be talking about some of the hidden costs of public cloud and do some in-depth analysis of public versus private cloud, and how, at the end of the day, this is not a critique against public cloud, but it's more how we can have and set up a either hybrid or multi-cloud strategy. So about myself, I'm Daniel Virassamy. I'm a principal solutions architect in Mirantis, and I live in Paris. I've been in the open source world for a long time now. Started my career in Linux, and then worked on OpenStack and Kubernetes since inception. I am curious by nature, but open source by choice, definitely. So this is the last of a series of 3 episodes. The first one, we discussed about why public cloud is on the way out. You can review again the video on BrightTalk. The second one was on-prem data centers plus public cloud, a perfect match. Again, you can see them on BrightTalk, and today we'll close this series, right? And we will close it with this meme. But let's directly dive into the topic, right? We know that we cannot forget about some of the costly services on public cloud. Obviously, when you are using the infrastructure piece, like VMs, some of the container services that rely on VMs, the storage, whether it is block, object, or file databases, right? These are the main and core services. But you have a lot of auxiliary services attached to it, which will start to add in some of these, what we call hidden costs, right? So load balancers is an example. Public IP address, when you are using fix and reserve public IP address, you have a cost attached to it. Whenever you are enabling monitoring stack or you want to have advanced metering, you will have definitely a cost attached to it. Data replication across regions, egress traffic whenever you want to push data out of the public cloud. Some of the services related to what we call the platform services, like IoT services, AI/ML. So all of this, they are adding costs, right? So you need to then add all of these costs and estimate or try to forecast how much at the end of the day your service will cost at a given time, and then how that will evolve over time. And this is where it is a little bit complicated. But for now, just let's look at a very simple example. This is a very simple example of a free tier application, where you have your first tier, where you have your load balancer, which would spread the traffic towards your application servers. Then on the second tier, you have the EC2 instances deployed in a single region across 3 availability zones. And then the last tier is your database tier, which is storing all the states of your application, right? You will also be able, and depending on the complexity and the scale of your application, you will be also attaching some other auxiliary services. Here we have S3, for example, to serve all the large files towards your customers. We are also using ACM to manage the certificates, CloudFront as CDN, and to provide traffic optimization across the world, and then Route 53 for the DNS piece, right? And if we do the calculation, if we calculate the cost of such an architecture, and it's not very complicated, right? You know that on AWS or Azure or GCP, you can go way more complex depending on the application that you are serving. And you can attach more and more services attached to it, like message queues, big data, document DB, and all that stuff. So in this case, for such an example, what I did is I created an estimate with 9 EC2 instances. So they are not very large instances, M5 2x large. So these are like 8 CPUs and a couple of 16 gig of memory. So they are not very large. But I counted 9, 3 in each availability zones. I have 1 large database. So this is M5 12x large with 1 tera of storage. I have an S3 bucket with 2040, so 2 terabyte of data, one certificate, one hosted zone, one load balancer, and 4 geos for CDN, right? And when I calculate all this, and this is a quick and dirty estimate that I made, that I can show you in this. This is the estimate, right? So we can then reflect the cost, and I can modify each and every of these lines. I can amend, I can change, etc., etc. I come back to a cost of of around 20,000 USD per month, right? So that's again a standard for a very standard infrastructure. If then I look at the for a year, then I am around 230,000 USD. Okay. If obviously I can optimize that, I can change some of the flavors. I can increase, reduce, modify, do as many geos, etc., to kind of try to reduce or ultimately have more cost, right, depending on the target environment. But again, for a very simple example of only 9 virtual machines, at the end of the day, I have only 9 virtual machines, one for a database. I am paying around 230K per year. Okay. Now, we just saw, or we just looked at a very simple example. But if we are looking at a more complex example, right, you will definitely need to do more work into doing that estimation, because it's quite hard to kind of build that cost estimate and then do the forecasting, right? And this is why today you have a new field which has been created and is definitely more and more popular, which is Cloud FinOps. And Cloud FinOps then work with your Cloud Center of Excellence and your Cloud Operations teams, right? So it's a virtuous circle where the CCOE is providing some governance and consulting to FinOps. The CCOE is providing governance strategy and best practices to Cloud Operations, and then FinOps is pulling data from CCOE and from Cloud Operations to build all the cloud financial management and operating models, and then provide all the dashboards to the decision makers, right? But this is very key, because without that entity, it is getting more and more harder to kind of understand actually what is happening in terms of cloud spent, and where or which services is being the more costly, right? And this is again a moving not architecture, but prices are changing constantly, right? And you need to adapt rapidly these pricing models, so that again you track properly and you are able to adapt your architecture and provide this feedback to CCOE and also to Cloud Operations, so that they monitor it in a better way, right? They also say that you would need less staff, for example, and again we covered that in one of the first presentations. Ultimately, I don't think that you will need less staff. You will need to have staff that knows how definitely to manage these clouds, right? Whether you are in a single public cloud strategy or in a multi-public cloud strategy. It's not me that is saying that, and DJC from AWS is himself saying that there is no compression algorithm for experience. So this means that yes, the staff that you will be, or the people that you will be hiring to take care of your public clouds will need to have the proper training, need to be certified for AWS, certified for Azure, certified for Google, right? So you will need to factor in the training cost for sure. You will also need to factor in the hiring cost, because it is also a change in perspective. As I mentioned earlier, you will need a FinOps team to build all the pricing model and build the dashboards for decision makers. You will have the Cloud Ops that will be doing all the operations and monitoring the platform and making sure that everything works. You will have your CCOE with the different responsibilities within the CCOE, whether it is architecture, whether it is security, whether it is program management. So, and all of this needs to work in relation, right? So basically, in that case, this means that either you will have your existing staff that will be trained to be part of these teams, and this is definitely a good strategy. But you will also need to bring in new people that will also have that the experience within these different entities, right? And this is only on the cloud piece. We are not even talking about the development and innovation teams, which are at the end of the day developing the services. and this is what at the end of the day you are selling to your customers, right? So do you need their staff? No. At the end of the day, you will need to factor in training, and you will need to factor in experts that would fit into FinOps teams, CloudOps teams, and CCOEs. Now let's look at the migration return on investment, right? Many cloud providers have been investing into the move to cloud initiative, right? So they provided multiple options to move from private clouds, VMware to public clouds, or VMware to VMware on public clouds. So you have these different ways of moving around from VMware to AWS, Azure, Google, or even OpenStack to VMware, Azure, and Google. These are funded. Typically, these are funded by these public cloud providers or even partners. But rapidly, the issues that many of the companies are facing is that after migration, with credits and or with a given cost, the cost of hosting applications from the private environment towards the public environment is increasing, and is increasing very rapidly, right? So it's getting out of control. So at the end of the day, you've moved from one entity to another entity. You are kind of locked into that situation, but you are seeing the cost. You are definitely seeing the cost increasing, and you are now facing these limitations. You also have the lock-in related to the egress cost, and we'll look at that in more details afterwards. And then obviously you're moving from like, say, for example, VMware to public clouds. It's a closed solution to another closed solution, right? It's not closed solution to open source solution like Kubernetes or even OpenStack. So how do you optimize then, right? You've migrated. We've seen that even for a simple model, where you have 9 virtual machines and one large database, it is costing around $240,000 USD per year. But once you have moved your applications from your private entity towards the public cloud, and even if it has been funded, you will at some point be starting to pay for these resources, right? And these resources typically now they need to run 24/7, 365 days per year. So one of the natural ways is to move back from OPEX to OPEX. Though the promise of the cloud is CAPEX to OPEX. So basically you pay as you go, and you don't need to reserve anything prior to using them. And that's one of the main promises in terms of flexibility of the public clouds. But when you look at the cost structure, you would definitely then need to move back from OPEX to CAPEX and use, for example, on AWS EC2 reserved instances, right? So AWS claims up to 75% of cost reduction. And yes, if you look at and you do the calculations, depending on how the reserved instances are made, or what are the boundaries around the reserved instances, then yes, you can achieve some cost reduction, right? So for example, you know that reserved instances are related to or bound to a region or the type of tenancy, whether it is shared or dedicated, the operating system, whether you're using Linux or Windows or macOS, and the instance family, right? You will be limited to per region, so you will not be able to have more than a given amount of reserved instances for a given region simply because of margin. AWS would definitely lock that into we'll have that within a limit because of guaranteed margins for them. Upfront and 3 years, right? So you're back to that CAPEX model where if you want to get that level of reduction, you will again need to have a commitment of 3 years and then pay upfront. And then you need proper forecast, right? Because if you are out of the reserved instances and you're back to the on-demand because of wrong forecasting or because of unplanned scale, then the cost will be definitely steeper from what you are paying, right? I also like the example from Netflix and AWS, right? Which Cloud Zero wrote, so a blog post. We will be sharing that as part of the after the presentation. But yes, Amazon does boast about Netflix as one of their biggest AWS customers, and that's true. Even though it's its own competing service, well, it has its own competing service, which is Amazon Prime, right? But within this article, we can see that definitely at scale, the cost is quite steep, right? Because Netflix is paying around like estimated 1 billion per year to AWS, and they need to at some point to start to also improve in terms of or improve in reducing the cost of the cloud spend. Okay. Another way of also optimizing on the public cloud is to move towards function as a service. So, for example, Lambda on AWS, right? So to move from the infrastructure services, VM services, VM-based services, towards function as a service, and this is where also you get quite some significant cost reduction. So there is a Deloitte research again, which will be linking into the documents that we'll be sharing with you. And this research claims up to 57% cost reduction compared to the EC2 instances, right? But that's also because of the way that it is built, right? You have the control in a more granular way with the duration of execution, so the amount of CPU that you are using. Instead of locking a whole VM with a given amount of CPU, now you're just looking a process on that given CPU for a given amount of time, then memory and the number of invocations, right? So you can map that to the underlying resources that are being used. But the main issue with that is definitely that in that case you are completely locked because these systems are fully proprietary. So if you're using Lambda, for example, yes, you have the cost reduction, but on the other side, right, you have the you can only use Lambda, and getting out of that, if you have written hundreds of thousands or millions of lines of code in Lambda, it's almost well, very, very difficult to move away from that, right? And that's a good segue towards one of the missing pillar, and I did mention that during the first episode of this series, and which is reversibility, right? And I believe this is very, very important. And why? Because of rules and regulations and geopolitics. So definitely, you need to have a way out at some point, and you need to have an easy way out with a cost-controlled way out. So cost control and improved margin is for your company is very, 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 very key, and for that also moving out data is essential, right? And then some leadership principles or decisions, which would at some point also inflect into the or reflect a company's strategy, which would basically say, okay, I don't want to have only one or all of my services in one public cloud, or all my eggs in one single basket, but I want to move them across different environments for various reasons, and also private clouds. But it's hard to kind of estimate the cost of reversibility, but we know that it's not immediate, right? Because once you have moved everything to the public cloud and you need to move them back towards your private cloud, it will take time. Like, for example, you need to move from any closed source solution that you've been using on the public cloud towards any open source projects, for example, on your private cloud. Very simple example, right? Databases. If you're using the DynamoDB and you need to move them back to Mongo, for example, then it will take some time, right? So better use directly on the public cloud the open source versions of these projects, and then it's easy. It will be easier to migrate them back, right? You still need to migrate data from that public cloud towards your private cloud, but at least it's the same. It will be the same technology. You will need also to reset that landing environment, right? You will need to rebuild it if you've reduced it massively or completely closed down your data centers. Then if you need again to build that data center for a given reason, then it will also take some time. Reacquiring these lost skills, this is something which also needs to be considered, because you do have some very specific skills in creating, managing, and maintaining a data center, or your own private clouds, and so you will need, again, most probably to rehire people so that you get back these skills. And then once you get these skills, you need to rebuild the team, the process, and the culture around that, right? So it's definitely not immediate, but this is basically, at the end of the day, what will cost you in terms of reversibility, because you will have both system existing and coexisting at this coexisting, and you will need to support the cost of both environments until you are able to migrate some of the or the required applications from your public cloud towards your private cloud, hiring people, and then definitely in terms of material, have an environment where you will be hosting these applications, right? There is also the concept of data and why data is so cheap on these public clouds. So I like that phrase, from friendly to scary. Yes, this is very true. At the beginning, when you start using the public cloud, you get a lot of good offerings, free tier vouchers, as we discussed during the migration section, right? You get all these vouchers and free credits to move your applications from on-prem to public. So, but nothing is ever free, right? So you start to onboard rapidly with the cloud architects your applications. You see that data is cheap, and you are scaling up, and you are putting more and more data, and then at some point you have that bill shock. And this is where it is difficult, because you've already put a lot of data in there, and you can't get them out easily because of the egress fees. So this is basically where you'll need to do the proper analysis in which data you really need to put into public cloud, and which data you can keep in your private environment, right? We know that this is a true cost factor to analyze and integrate when you are having that move to the cloud strategy, right? And what would be the cost of getting them out if you are to be reversible for various reasons that I highlighted before. But if you look at the different options, whether it is OVH in France, in the US, Azure, Google, and AWS, definitely the free public clouds are way expensive, more expensive than the rest of the players in that domain in terms of egress cost, right? And which is normal, because this is the same as for Lambda, for example, and function as a service. This is a very easy way of locking people in. So in that case, the recommendation would think about repatriation upfront, right? And to do that is there are a couple of simple things to do. The first thing is use the cloud spend as a KPI, right? One of the KPIs. Obviously, there are some other very important KPIs that you will be taking in as consideration when you are using the public cloud. Some of these KPIs is definitely the flexibility, the ability for your teams to develop rapidly applications to host your and serve your customers, right? But cloud spend is also a very important KPI. And actually, when you look at some of the articles around Netflix on AWS, this is something that they have built, right? They are putting in perspective their cloud spend versus what they are gaining in terms of customer satisfaction, obviously, but also revenue from customers, right? And there is a strict not surveillance but monitoring of the cloud spend to make sure that they are in terms of cash positive and all that. So once you have done that, right, then you can build proper incentive towards your teams, so that your teams would be adopting the proper behaviors in cloud spend, right? Again, that can be a little bit tricky, because then you may lose a little bit of that flexibility and the culture behind the cloud, which says, okay, go and have, this is a playground, and try to do or try to innovate. But again, if you don't build that type of incentive and to build or to nurture the right behaviors, then you get in a risk of increasing the cost in an uncontrolled manner, and then obviously get that bill shock, right? Optimize, and optimize again. This is something that you need to do. You can't have in your company, or you don't have a lot of room for religious dogma, right? So what I mean here is that yes, cloud is bringing on the table a lot of good things, right? But definitely you need to optimize the way that you're using the cloud resources. And again, how you're bringing in data into the cloud so that you don't you have a way out if required, or you have a way of controlling the cost. And then Kubernetes, right, as the cloud operating system. And this is for me the main item in all these different different points, is that Kubernetes is the cloud operating system, right? And this is true across all the different clouds, whether it is public cloud or whether it is private clouds, right? The common denominator would be Kubernetes. You know that when you are using Kubernetes across these different environments, you have a way out. I'm not talking about data, I'm talking about the applications, right? And you have a way out to get your data back and move them towards another environment, right? Simply because Kubernetes is made to run across all these different environments. And you have a lot of ways today to also migrate data, migrate your application rapidly from one given cluster to another given cluster, right? You still have that data mobility problem, but this is more about data governance. Which data needs to be in public cloud and which data needs to remain on private, right? And this is very, very key because you have that data governance. But once you have built that data governance, then you can use Kubernetes as that underlying cloud operating system that will allow your applications to be easily deployed in each of these environments and then move them across when required. So the solution, I'm not going to talk about any revolution, right? So keep it simple. One thing is, I think we need to think about multi-cloud and adapt how we are moving and how we are doing the proper data and app placement, right? And that's what I was talking about. So I'm not going to talk and say public cloud is better or private cloud is better, or it's a war between them, or it's either public cloud or private cloud. I think that that's not the point of this presentation. The point of this presentation is that, yes, public clouds with an S and private cloud can work together, right? And this is the multi-cloud approach. And this is what we are seeing more and more in many of the companies, right? They don't want, again, to put all their eggs in one single basket. You will take the best from AWS, you will take the best from Azure, and you will take the best from Google, and they are providing superb services. But also you do want to keep a private environment where you will be hosting very critical data that you don't want to take back at some point at a high cost from these public clouds. That some of the data you can't put in the clouds because of sovereignty reasons, or because of security reasons, or because of so the sensitivity of attached to these data. But you will always have Kubernetes as that underlying cloud operating system to move around your applications from one side to the other, right? By keeping also a private cloud, you also keep skills. So you keep your internal skills and you don't lose them, because once you lose these skills, it's very, very hard then to get back these different skills. So yes, proper app and data placement. Definitely, you will always need to do an intelligent application assessment and build these intelligent reports, right? Always, right? If you have that move to cloud strategy, at some point you will be analyzing your internal application portfolio, and then you will apply the 5 R's or the 7 R's, right? So definitely you will need to do that application assessment. And ideally, if it is automated and if it builds intelligent reports, then that's even better. Once you have done that, then you have your data governance. Sorry, it's not a data governance. There's a typo, but it's data governance. And once you have that data governance, then you can consider where you will be placing this data. Data definitely is the new oil. You have the concept of data gravity, which means that once you have put your data somewhere, you know that your applications will be around that. And that's why data is so cheap on the public cloud. But again, there is more than only, okay, it's cheap and I can put it there. It's okay, what's the cost of getting them back, that data back, but also basically, can I put that data there, right? So once you have that data and you have that, you did your data governance and you decided where you will be putting some of the data, then definitely you will need to have the compute capabilities around that data, right? So basically in your private cloud and in your public clouds, right? You will need a single pane of glass to manage all this, and with Kubernetes, that simplifies a little bit the approach, because you have a lot of tools to provide you that single pane of glass to manage and see what is happening across your different clusters. Lens is a good example. Lens is an IDE that allows you to have the visibility across various environments on multiple Kubernetes clusters and various technologies, right, or various distributions of Kubernetes clusters, whether it is Mirantis Kubernetes Engine, whether it is Rancher, whether it is Tanzu, right? So you can all add these in a single pane of glass and see what is happening. And if you need other and extra capabilities like billing, etc., you can just add these components in your Kubernetes clusters and observe them through that single pane of glass. And yes, run everything in Kubernetes, but I think I've already covered that at length. So private does not mean on-prem, right? And this is something that we also want, as Mirantis, we also want to make sure that we're not saying that private is on-prem. We can be, yes, our customers can have their own data centers, but they can also be in co-location sites. We have some examples today where you are able to get that level of flexibility also from hardware vendors. You have Equinix Metal, for example. Equinix Metal is a partner of Mirantis. And you have pay-as-you-go model, right? You can pay by hour physical servers and then deploy and a technology stack on top of that, whether it is OpenStack, for example, if you need virtual machines, or Kubernetes if you are going to host pods on that cluster. And then when you don't need them, you just stop the physical server and release it, and you stop paying for that, right? But you can also move back towards a contract to get cost reduction, the same as what you will be doing with reserved instances in public clouds, right? You also have the multi-region approach with Equinix Metal. So again, you have various regions, whether it is in Europe, whether it is in the US and in Asia. So again, you can build your own private cloud on Equinix Metal, but with the same level of availability, resiliency, and flexibility as public cloud. You have also HP GreenLake, which is also a pay-per-use model. And in this case, you can deploy that in your own DCs, in colos and edge, right? And for example, you can see in this example where we have mixed everything. And this is your own data center on the left side. You have your colocation in the middle, where you have Equinix platform, for example, but within the Equinix platform, you can also deploy HP GreenLake, right? And then you have connectivity towards public clouds, right? Whether it is AWS, GCP, Azure, Oracle Cloud, and others, right? And in this case, you are setting up your multi-cloud strategy, because you have your own data centers where you have your legacy applications. You can put some of the more OPEX-like model within Equinix with HPE GreenLake, and then you still and you are connecting your other services with your public cloud accounts, right? One thing which is also very important, and we get that concern. The concern is, okay, I'm going to move back to, or I'm going to still use private clouds, but I like also the simplicity of public cloud. I like the way that or the fact that I'm logging in public clouds and I have all the services available, and it works, and I don't need to create or I don't need to create tickets, even though you do have sometimes to create tickets because of something not working properly. But yeah, it's working very well, and it's stable, and I just can concentrate on building my applications and delivering value to my customers, because everything is great, right? And with Mirantis, we then started to build the approach of ZeroOps, and we said, okay, that's a good statement that public cloud is simple and is made simple, and that you have that many services. And we can also do the same with what we call the ZeroOps approach for private clouds, right? So whether it is on-prem or whether it is in colocation. In that case, what we are saying is that your teams will be able to have the same user experience as public clouds, but on a private environment, right? So they will be able to concentrate and build their own applications and deliver value and innovation to your customers, and not do or not take care of things that you don't want to do. And how we do that, and what do we encompass around ZeroOps? We have products. We have products for virtual machines. We have products for containers with Kubernetes, right? They are all based on open source. So again, we are very, very attached to that concept of reversibility and sovereignty. So these are based on open source projects. So if at some point you want to take back or deploy your own open source projects based on the components that we are using, you have the freedom of doing that. You have a support plan attached to these products, which we call customer success. You have professional services to help you start using these products by onboarding people, by designing clouds properly, by helping integrating some of the components within the solution. And we also have training again to help your teams to use the solution properly, or operate the solution if you want to operate the solution, and be certified on these technologies. Again, these technologies being fully open source, right? And this is what we call ZeroOps. The model is very, very simple behind the products. It's a per node or a per core model, depending on which one is better in terms of cost, right? Typically, at a small scale, the per core is more cost efficient, but at a higher scale, the per node is more cost efficient. So that's why we have these two models. And depending on how our customers are embracing the technology, and at the scale at which they are embracing the technology, we adapt the pricing model so that it is more cost efficient for them. Right, so it is a very, very simple model, and you don't need to have, you don't need to have a very complicated, at the end of the day, very complicated calculator to kind of understand how you will need to price the platform. And at the end of the day, also the forecasting is much more easier. Okay. When it comes to the support, we have two, and that's what at the end of the day you are paying, right? You are paying the support subscription because it's open source that we are shipping. You have two approaches, one which we call OpsCare and one which we call OpsCare Plus. So the OpsCare support model is it's also called a co-pilot, right? Or it's a co-pilot approach where you are still supporting the platform, you are still maintaining the platform, you are the owner of the platform, and we provide you assistance, right? So it's a 24/7 engagement. We are monitoring the logs and alerts. We are proactively engaging with you by doing the proper monitoring of these metrics and proactively indicate that yes, there may be some issues in terms of capacity, and you need to make some changes, etc., by adding more nodes or by optimizing the nodes or removing some of the unused resources on these nodes. We will provide the reporting, do the lifecycle management with you, by supporting you. We have guaranteed SLAs. We have a customer success manager that will accompany you, and we provide assistance for operations and change execution, right? So we don't do it directly, but we provide assistance because you are still the owner of the platform. And we have the other offering, which is called OpsCare Plus, and this is a fully managed offering. In this case, again, it is a 24/7 support. We do log and we monitor the metrics, the logs, and the alerts. We proactively engage again with you, depending on, for example, we do capacity planning with you, and we would definitely advise you or recommend some strategies based on how we are, what are the trends that we are observing. We do the reports, whether it is monthly reports or quarterly reports or annual reports. We definitely, in that case, do operations and change execution because it's a fully managed service. And we do the lifecycle management by updating and upgrading the cluster. We have guaranteed SLAs. We work with third party and we integrate we have third party that can be integrated, and we will be the single point of contact to also engage with these third party partners. Like we are a partner of Tradio, for example, for backup and recovery. We are a partner of Portworx for database as a service. We are a partner of Sysdig for security items, right? So we have that list of partners that we can integrate within our platform, and we can be that single point of contact. You will also have a customer success manager that will be your point of contact, and you can have a minimum subscription of 1 year or 3 years also, right? Very similar to public cloud. Then about the landing zone. So I talked a lot about Kubernetes. So this is a very simple way for us to deliver that Kubernetes stack, right? And we can do that in a very, very short manner. So we can move from design to run in less than 1 hour. You have Mirantis Kubernetes engine at the core of the solution. So this is the engine, the Kubernetes engine itself, which uses Mirantis container runtime as the container runtime, right? So this is Docker Enterprise Edition that we are using with FIP certification, and that can run on both Linux and Windows operating system. You have a multi-cluster management system that monitors and deploys a logging, monitoring, alerting stack on top of Mirantis Kubernetes engine, and this is what we are then using to deliver the OpsCare Plus offering. We also have Mirantis Secure Registry, which is a private registry that you can use to host your container images, and then we have Lens Autopilot for the single pane of glass to monitor all your different clusters using Lens. But also we are able to enforce GitOps approach, where using Fluxcity, we are able to deploy various components into Mirantis Kubernetes engine, whether they are open source components or closed source components, right? So through our partners, we are able to use this Fluxcity tooling to deploy these components and manage them using GitOps procedures, right? At some point, if you also need to have virtual machine capabilities, or if you need to have Mirantis Kubernetes engine, for example, to run on a virtualized environment, we also provide as the underlying layer Mirantis OpenStack, right? And within then Mirantis OpenStack, you will have not only the capability to manage virtual machines, but also storage capabilities with Ceph, because we embed Ceph as a software-defined storage. And you have an SDN, or a complete SDN with macro segmentation capabilities with OVS or Tungsten Fabric. So Tungsten Fabric is the open source version of Contrail, right? So Juniper Contrail. Okay. So again, within that very simple pricing model, where you have a per node subscription model, you have everything included. You have the OpenStack cluster, the Ceph cluster, and the SDN cluster. It's one single pricing, per node pricing, and you have that full stack offering, right? So again, design to run in less than 2 weeks. And how we do that typically is we engage with our customers to do an ADA. An ADA is called an architecture design assessment. So we work with our experts and your experts to build that cloud. And this is where we will be assessing the hardware. This is where we'll be optimizing the cost of the required hardware at the scale, the amount of nodes that you require, so that it's not only going to be resilient or efficient, but it's also going to be cost effective, right? So we work with you to design that, and once this is done and the hardware is available, whether it is in your data centers or in colos, Once this is available, then we can deploy very rapidly the solution, and then you have the full capabilities with virtual machines, storage, SDN capabilities, and then Kubernetes on top of that, right? And once this is done, then if you need any extra services, then we can work with our partners to onboard these extra services. Again, like Tradio, for example, for backup and recovery, like Sysdig for security, PDS, Portworx PDS for database as a service, Cloud7 for billing. We can embed all these different partners to make something aligned with your application requirements. And once I've said that, then we can come back to the initial calculation where I had 9 virtual machines, EC2 virtual machines, plus 1 virtual machine for a database, right, which was costing me around 230K per year with the parameters that I set for this architecture. And here in Mirantis, if you go to that link, we made a very simple calculator to compare VM to VM, right? So it's a simplified model to compare VM to VM, okay? And in that model, if you look at what I did is I considered one single region, okay, one cloud, so one deployment of OpenStack, and one region for AWS, right? So let's say, for example, Paris region. And then within that region, I'm deploying 15,000 servers, right? So 15,000 servers, if you consider 50 servers, 50 VMs, sorry, 15,000 VMs. So if you consider 50 VMs per physical servers, then this is 300 physical servers, right? If I put 52 CPUs in a physical server and 1 terabyte of memory in a server, then I have that amount of available CPU with an overcommit ratio of 1:8 and that amount of memory, right? And if I do that, then I know that it is quite close to C5 to X large instances. In that case, if I consider that one physical server is around $18,000 dollars, including Mirantis subscription, right? Then you have a cost of around $382 per VM per year. Okay. If I do the same for AWS with C5 to X large instances, and I factor in, because of reserve instances, for example, I factor in a 50% cost optimization, then I am around $2,000 USD per EC2 instances per year, right? And over 4 years, then if you do the calculation, you will see that you are saving around 115 million USD, right? So at scale, if you look at that scale, you can see that VM to VM, in a VM to VM comparison, you do have a cost reduction when you consider solutions like an open source solutions like OpenStack, right? If you're optimizing in terms of hardware, if you're optimizing in terms of the amount of VMs that you are putting on top of that hardware, because here I just considered 50 virtual machines on one single physical service, right? But now you know that you are getting these more and more optimized physical servers where you can have a lot of CPUs and a lot of memory, and you can put even more virtual machines on top of these physical servers, right? And as you put more and more virtual machines on these physical servers, your cost will go more and more, will be lower, right? Will go down more and more. So, and these are some of the ways that you can definitely improve that cost, right? So here I gave 15,000 virtual machines, but yeah, you can even go lower than that, right? If I go to the calculator here, and I just consider here, sorry, not 15,000, but just only 1,500 virtual machines, right? In that case, you still can see that there is a difference, right, between 2,000 for an AWS instance per VM per year, and for OpenStack, this is around 517 per VM and per year. Okay. knowing that, yes, you have the same then user experience with a fully managed offering for OpenStack or for your private cloud, and then a self-service approach in your public cloud, right? I also factored in 15% growth over the 4 years, so that's why you are seeing the cost going down for OpenStack, and then slightly going up for AWS, because the cost is pretty linear for AWS. Once you don't have a volume effect. Once you have your discount applied to your EC2 instances, then it just grows as you use more resources, right? So that's a very simple model. If you do want to get more details from us, we do have a more complete calculator within Mirantis, where we have over 15 variables, and here we can tune a lot of things. We can tune the model of the hardware. We can tune the amount of people that would be in your team, or if you're in a fully managed mode with us, then the amount of people that would be required to operate the cloud with us. The cost of electricity can be factored in. The number of regions will be factored in, right? So we have more variables that we can tweak, and we can give you definitely a more precise cost difference between OpenStack and AWS, but we have also OpenStack against VMware or OpenStack against other cloud providers, right? So we have that ability to tweak that. Do not hesitate. If you go to our website and TCO calculator, you can schedule a call with us, or you can contact us, and we can do that together, so that you see the differences or the cost optimization that we'll be able to do by selecting a private cloud solution based on open source solution like OpenStack or even Kubernetes, right? It's OpenStack and Kubernetes. It's OpenStack alone or Kubernetes alone, right? So you don't need to use the full package, depending again on your application requirements, right? And if you do need, or if you want to get more details, again, do not hesitate to contact me or contact Mirantis at mirantis.com, and we'll interact. All right then. So again, thank you very much for your attendance. I hope it was useful, and I hope the free episodes of this series was useful. You will be able to watch them again on BrightTalk. If you do want or do need to have more details, please reach out again. Do not hesitate. I wish you a good rest of your day, good morning, good afternoon, or good evening, depending on where you are, and looking forward for the next webinars that we'll be doing. Thank you very much.